today we are looking at how different charges in a rectangular shape affect the force on a charge of interest. So in this case, our charge of interest is the 5 nanocoulombs. So we need to begin by looking at what the individual vectors on this charge are, given the other charges that are acting against it. So we will start with the 2 nanocoulombs. So we know that like repels like. So in this case, we know that since we have 2 positive charges, our initial vector will be in the opposite direction. So we'll go to vector in this direction. We then move on to the 7 nanocoulombs. So again, we know that like repels like, so we will get a vector that goes in the opposite direction. And finally, we have our negative 3 nanocoulombs. So we know that opposites attract, which means that we will get a vector that goes towards the negative. So at this point, we need to determine what the individual vectors forces are to determine the overall force on the 5 nanocoulomb charge. To do that, we will call the 2 nanocoulomb vector F1, the 7 nanocoulomb vector will be F2, and our 3 nanocoulomb vector will be F3.
So to determine each of the forces that this 5 nanocoulomb charge is experiencing, we're going to use Coulomb's law, which states that the force between 2 point charges is equal to K, Q, Q, over the distance between the 2 charges squared, where the Q's are the charges of the 2 point charges and K is a constant. So since these are all point charges experiencing, placing a force on our 5 nanocoulomb charge, we can use Coulomb's law since it is not a distribution of charges. So we're going to go through and do the math using Coulomb's law for each of these 3 vectors. So for each of these individual vectors, we're going to call this 2 nanocoulomb charge big Q1. This 7 nanocoulomb charge is going to be our big Q2. Our negative 3 nanocoulomb charge is going to correspond to big Q3. And our 5 nanocoulomb charge is just going to be our little q. So applying Coulomb's law to each of our charges, you can see that we get 3 different answers for the magnitude of the force. For our 7 nanocoulomb Q2 charge, we have to divide our vector into x and y components since this vector does indeed have x and y components. So using the hypotenuse of this line, which is the square root of 4 centimeters times 6 centimeters, both of those quantities squared, the addition of the 2, we can use the angle between them using inverse tangent to get our theta to find our x and y components. And for our forces 1 and 3, we can see that those only have one component. In the case of force 1, it only has an x component. In the case of force 3, it only has a y component.
Alright, so the next step is to take the different components that we received for the forces over here and add them together in order to determine the magnitude. So right here we took the components in the x direction, so the F1 force and the cosine of the magnitude of the F2 force to receive this value. And then for the y, we took the F3 force and added it to the magnitude times the sine of the F2 force and to receive this. To receive the overall magnitude of the force, the force vector acting at this charge, we then took the square root of those 2 components squared and added together to receive this overall magnitude. And then to get the angle of the resultant force, we then took the tangent of the y component over the x component to receive 34 degrees below the x-axis. So this overall force acting on the 5 nanocoulomb charge would look something like